Good morning, good afternoon, good evening, everyone. Welcome to this part 9 of our digital color management fundamentals. It's gotten to that point where Ken, our color expert, will be talking to you today about how you put everything together. So, Ken, I'm going to hand the floor over to you.
Thanks again, Chen, and thanks everyone for joining us again today. I hope you've had the opportunity to join us for some of the earlier sessions. If you haven't, certainly feel free and go back and review those at your convenience. A lot of the points we'll be talking about today, we'll be putting together the concepts that we've been going over in each of those sessions. We're not going to actually be using live software today, but we do want to look at all the different technologies, both hardware and software, that are required to really put together a total digital color management workflow. So when we think about digital color management in retail apparel, there's several basic categories of steps that most of you are probably familiar with that we go through in the process of developing colors for the retail apparel market. We start with a specification phase where our goal is to come up with a seasonal color palette. Designers or merchandisers are looking for inspiration in the world around them, and they're taking those inspiration colors and they're building their color palette. That can take several weeks to accomplish that task, say 4 to 6 weeks. Once we have our seasonal color palette ready, then we're ready to actually develop those inspiration colors into a color standard that can be sent out to the supply chain. In many cases, we are going to find that an engineered color standard is already available from a standard supply company such as CSI, Color or Chroma, or others that are out there. And in those cases, it's a relatively simple process to communicate to the supply chain exactly which color standard they need to order and to develop on whatever the specified materials are. In some cases, though, you may find that you want to develop a custom color standard. And if you're going to do that, that can take several weeks, up to about 4 weeks to get a final color approval, even before we begin the lab dipping process. Once we have our color standards ready and the suppliers are in possession of those color standards, we then start the traditional, what we call lab dipping process. If you're not familiar with that term, lab dipping is an old textile term. Came from the fact that originally when dyers were dyeing fabrics, the fabrics would be dipped up and down into a container of dye stuff solution. Certainly the process is much more sophisticated today, but that process still takes time. The supplier will receive from you a color standard. They will select the dyes necessary to match that shade to meet the end use requirements and whatever costing or runnability or fastness requirements also exist. And they'll submit those samples for review to their customer, who will then either reject or accept, give comments, and then we'll go through an iterative process until we get an approval or until we run out of time. So in many cases, we run out of time before we actually have something that's, quote, perfect. And we end up with a best can do situation. That can take 6 to 12 weeks, depending upon any issues you may face with the colors you're working with. Once you have a lab dip approval, then you're going to move into the initial production process where we're going to dye our first production bulk. And that sample is typically going to be compared back to either the approved lab dip or to the engineered color standard. And most likely going to be submitted back to the customer for approval. That process can take 1 to 2 weeks. The goal, of course, is then to be able to move on into our ongoing quality assurance, where we are now dyeing whatever the number of lots of material are necessary to fulfill the order, and creating what are typically called shade bands. Depending upon how long a color is in production, you may see that color will run for months or years, especially if it's a color that's used in programs that carry over from year to year, such as team sports. That process also takes 1 to 2 weeks initially. Overall, though, when we look at the amount of time it takes to get from the initial design process for selecting color until we have color in production, that can take 16 to 26 weeks. So it's 4 to 6 to 7 months, so often longer. So the color development process can begin, in many cases, 6 to 9 months prior to actually needing the products in the store. A few other conclusions we can draw about the textile apparel color development process is that, first, the apparel industry is global, even for small companies. So no longer is it the case that a retail apparel company can connect with a supplier who is a simple car drive or domestic flight away. That may be true in some countries, but generally speaking, when we talk about retail apparel brands, their supply chains are going to be global. And they have a significant need to communicate color preferably instantly. Right now, we are relegated to sending samples by shipping services, sometimes overnight. That can be very expensive. The ultimate goal, though, is to share the results of our color development instantaneously. We also find that there is significant pressure related to shorter product cycle times. Now the calendars are shorter and we need to make decisions closer to the in-store delivery date so that we can be sure that we are meeting the expectations of the consumer. And invariably, they're going to be last-minute additions. So there was always going to be this pressure about time in the color development process. But that color development process can't hold up delivery. At the end of the day, you have to have products in the store available for an online purchase, and that date is going to drive everything that happens in the days, weeks, and months prior to that. But the color, of course, is a key part of the overall experience of the consumer. And our ultimate goal is to ensure that the customer sees what the product designer intended. And no longer can that take the 26 weeks that it has been taking. It's got to be done faster. And companies are doing this regularly. There are a number of companies, and here are a few that we've surveyed, that spend a significant amount of money on the color development process. If we look at these 7 companies, we see that there's a significant range in the number of solids and print strike-offs that they're developing. If we take company A, for example, they're developing 200 colors per year across various materials. That represents about 25,000 lab dips. If we use the average cost per lab dip of $100, we find that that's an investment of about $2.5 million just into the initial color development process. Now, granted, that's not money that the retail apparel company pays out of pocket to the suppliers, but that is a cost the suppliers will incur, and so it is going to be built into the final cost of the goods that are being purchased. So it's not a realized cost in that sense, but it is a real cost that's going to drive up the price of the products that the retail apparel customer is purchasing. If we look at an extreme, line F, this company does 240 new colors per year on a significantly higher number of materials. About 150,000 lab dips are evaluated per year at a cost of about $15 million. When you factor in print strike-offs, as in with company C, those were typically run at about $200 per strike-off as an estimate, because there are other components and processes that have to be accounted for. We're looking at about $8.75 million. So for these 7 companies, in the course of a year, we're spending close to $60 million just in the color development process. And this is invariably sending physical samples. This doesn't account for the shipping costs of getting those physical samples from the supplier to the retail apparel customer, nor does it account for the time that it takes for that process to occur. So we really need to ask ourselves some questions about this overall color development process. Firstly, how do we improve the accuracy of color submissions? So rather than having to send 2, 3, or 4 rounds of submissions to get approval, how can we ensure that the first round is going to be acceptable, and that's the only round we have to look at, as well as the only round of physical samples that we're going to ship? Secondly, how do we reduce the time required to reach that color approval? How can we shrink that color development cycle from 12 to 16 weeks down to 2 to 3 weeks? And of course, that's going to give us the opportunity to make decisions about final color selection closer to the dates when those products need to be in the store. And then finally, how do we ensure ongoing quality of production material? And that's ultimately our goal, is to be sure that the consumer's experience is positive, that the ideas that the designer has come up with actually land in the store, and that the customers are satisfied with those products, because that's ultimately what they purchase. They don't purchase lab dips. Well, the only way to really address any of those questions effectively is through a digital color management process. And that means measuring color samples and using software to evaluate color quality. Now, if you've attended some of our previous sessions, then you're probably already familiar with what a digital color management workflow looks like, but let's just run through some of the basics of that for those of you for whom this might be new. So when we talk about digital color development, we're talking about a process of making a measurement of a color. We actually measure the color with a special device called a spectrophotometer to produce what we call a reflectance curve. Think of it as the digital fingerprint of a color. Just like each person has a unique fingerprint, every color has its own unique set of reflectance data or fingerprint. Once we have this data electronic data measured, then rather than sending the physical sample from our retail apparel customer to our supplier, we can send the digital data. We can send it electronically by email, download it from a website. The term that many people are familiar with is called a QTX file. A QTX file is simply an industry standard file format that contains reflectance data that can be imported into a variety of color management software solutions. Now, once the supplier has that QTX file, even before they have a physical standard, they can go ahead and begin their formulation process. In this case, they're going to use software such as Data Color Match Textile, which enables them to accurately identify the dyes that are necessary to match that shade within the cost constraints and to meet the certain performance criteria of their customer. So they will dye those samples and then they will evaluate those electronically against the original color standard. Now keep in mind, this can all be done prior to receiving the physical color standard. We can actually measure our lab dip, compare that to our electronic standard and get an idea of how close that is to our standard and make corrections before sending physical samples. And this is really the most important part of the process. The supplier should not submit a sample until they are confident that it's going to have a significant chance of success. Or perhaps they're going to have if they have a problem, they want to send that data to review that with their customer. But they're going to evaluate the pass-fail acceptability of their sample using the tools available to them in the Data Color tool software. Now, once they have samples they feel have a high chance of approval, those can be submitted digitally, again, in the form of a QTX file by email or via any other sort of platform that's going to be used for sharing data. But this digital file, once it's received by the retail apparel customer, can then be evaluated in their software, both numerically as well as on screen in a color calibrated environment. And when combined with fabrications such as twill or poplin or a rib knit, those samples can be viewed on the calibrated monitor in what we would call a virtual light box. So the retail apparel customer has the opportunity to make a decision about color quality without actually seeing the physical samples. Now, if one of those samples is acceptable, they probably will go ahead and request a physical sample because everyone likes to hold the final sample to make their final visual approval. But if none of the submitted samples are acceptable, that's where the retail apparel customer can reject the sample and make comments and send those comments back to the dyer to ask for a second submission without actually seeing the physical samples. So even though we may have to go to a second or a third round, we've at least eliminated the cost and time associated with shipping those physical samples. So in the end, we're left with a process that ensures that the first physical sample the retail apparel customer receives has a high degree success rate. So we're confident that that sample is going to actually pass when compared to our standard. Now, there are a number of elements to be sure that this happens correctly. So when we think about the big picture, what do we need to make this digital color workflow work successfully? At the heart of it is the instrument. So because we're sharing data, we want to ensure that we are working with what are called close tolerance spectrophotometers. That means that the instruments measure almost identically to each other. So if I measure a standard on one instrument, then I measure that same sample on another instrument, the results will be very, very close. In effect, eliminating the need to send the physical sample. Well, traditionally, the solid color samples have been the only types of samples we can measure in a close tolerance fashion, and for that, we use the Data Color 800 series of instruments. These replace the Data Color 600 series of instruments, but they are still compatible, assuming that the 600s, well, and the 800s as well, are maintained correctly and serviced on a regular basis and are using diagnostics on a regular basis as well. Well, historically, we've only been able to ever measure solid colors with these close tolerance instruments, but that only represents about half of what most companies are developing season to season. So about half the products they're working with, you can't actually measure with a traditional spectrophotometer, and for those, you're left with making a visual assessment. But Data Color has released a new technology called hyperspectral imaging in the form of the Data Color SpectraVision instrument. And that instrument is designed to measure traditionally non-measurable materials. So anything that has multiple colors, such as a textile print, or open structures such as lace or mesh, or even multicolors such as heather, small samples such as yarns, zippers, buttons, really you name it, those types of instruments can be measured on the Datacolor Spectrovision system. Now, it is new technology that we call hyperspectral imaging. Rather than making a single measurement that produces a single reflectance curve for everything in the aperture, we're actually taking a series of photographs at 10 nanometer intervals to capture the reflectance of every single pixel. So within this image, we're going to actually have 640,000 reflectance curves. We don't need that many reflectance curves, so the next step of that part of that process is using the software to actually isolate similar pixels within the image to produce a final reflectance curve for each of the distinct colors in the image. So as the example of this print, there are 4 distinct colors, so the Spectrovision system is going to produce 4 distinct reflectance curves. Once you have reflectance curves, the rest of the process is exactly the same as it is when using the traditional color measuring instrument. You have a reflectance curve, you can perform colorimetric calculations, you can look at color on screen on a calibrated monitor. So those are the 2 most common technologies. And as I said, there are a number of materials that you can measure with the Spectrovision system, including high power materials such as yarns, heathers, prints, lace, mesh. Really anything is now going to be measurable with either of these 2 instruments. There are going to be situations, though, where you want to have portability. So as useful as the 800 and Spectrovision are, the only way to measure samples on those instruments is to bring the sample to the instrument. If you're working in an environment where that's inconvenient, or you don't want to deal with the time lag, such as a production environment, in those cases, it can be very helpful to carry an instrument to the material itself. Now, there are a couple of options for that. There are sphere-based instruments, such as the Datacolor Check 3 or 450 based instruments such as the Datacolor 45G. So depending upon the application, one of the other instruments is more applicable. Now these are very good instruments. They are, because they're handheld, you are going to have some additional variability due to sample presentation because it depends upon the user being able to accurately present the sample to the instrument, but they're excellent tools for giving us the ability to make color measurements out on the production floor to get an instant decision about acceptability. So that's going to address the production needs, but on the front side, when we think about design, historically there have not been any tools to support designers in a digital color management workflow. But now we have devices such as the Datacolor Color Reader Pro and Color Reader that are geared more towards what we call ultra portable color measurement, so that designers can now make measurements as well. The traditional process is for a designer to go on a shopping trip, perhaps purchase a garment or discreetly clip a corner from a garment, or collect materials wherever they may be for inspiration, then go back to the office and then try to match those inspiration colors to either a color standard provider library or to their own color library. And that's a tedious process that requires a lot of time, and there's also a delay. But with the Color Reader Pro, the designer is able to measure that color using the device and their mobile phone application, wherever they might be in the world, to immediately search the color library of a color standards provider, such as CSI or Color, or even search their own color library if those have been measured in. What they are then able to do is to see on screen the closest matches to their inspiration color and to select one and then share that. So they can create a palette, they can share that with their color office, and the color development process can begin immediately rather than waiting for them to come back to the office. Likewise, if you have a Color Reader Pro in your color library, when you come in and measure your sample, very quickly you can identify the colors that are the closest match in any of the libraries of interest. But again, really the goal of Color Reader Pro is to introduce digital color management at the earliest phases of our textile retail apparel color development process. So along with that, you have some auxiliary types of devices that are essential for the whole color development workflow. They aren't necessarily going to be devices that produce digital data, but they are still critical for the entire process to ensure accuracy and repeatability. Since we're always going to be looking at color samples in a light cabinet for final review or for other criteria, you always want to be sure you're using standardized lighting. So a light cabinet of some description is going to ensure that. On the dyeing side, using repeatable lab dyeing equipment that correlates well to production, as well as dispensing equipment that eliminates errors due to dyeing. All these things work together to ensure repeatability in our process. Well, we also have to have software to go along with our hardware technology, and for the manufacturer, for the supplier, the mill, whatever the terminology is you want to use, they will typically be using the formulation software of some description so that they can generate accurate formulas for the color standards that have been submitted to them for development. And then both the supplier and the customer should be using color software of some description for quality control assessment, comparing standards and batches to ensure that samples are within an objective tolerance rather than using a subjective visual process. A significant component of the digital color workflow is evaluating color on screen. So if you want to be able to visualize that color, and again, we had a lengthy session on this entire process, so you can go back and review that in more detail. But basically, the requirement is that you work with a high quality monitor, such as a ISO color edge line, and that monitor be calibrated. The Spider 5 device is used for monitor calibration. That ensures that colors that are within gamut of the monitor are going to be displayed as accurately as possible so that you can make decisions based upon what you're seeing on screen. Once you've got all your samples dyed in production, historically there's been really no easy way to share that data, but Datacolor has recently introduced the Datacolor Color Hub product, which is an online web-based on-demand system for evaluating production data. So prior to the availability of Color Hub, the only real way to share the digital data is for the supplier to actually measure those samples and export that data to a QTX file, send it by email. The customer imports that QTX file and then makes their assessment within the Datacolor Tools program. But of course, that takes a lot of extra time. So with Color Hub, we've introduced an automated way of working with that production data. The supplier simply enters the information that's requested of them, such as the fabric or the lot number, into the Datacolor Tools screen. They save that into their database, and that information is automatically synchronized to the Color Hub platform. The retail apparel customer, as they navigate through Color Hub, are able to see all of the mill production data. They can isolate production problem colors, any specific lot concerns. They can look at a mill dashboard to gauge overall performance. And then from this, information can be exported to Excel for additional analysis or even generate reports to help determine whether or not the mills are complying with the production expectations. Now, this is actually a vital part of the entire process that's often overlooked. And in many cases, in many companies, there really no energy or no time is put into evaluating production. Once the initial production best case has been approved, ongoing production quality is left to the supplier. And that's not necessarily the best situation. While we do have solid relationships, there still needs to be accountability and oversight to help identify those suppliers that are putting in the extra effort and who should be rewarded perhaps with more business. And that's exactly what Color Hub is designed to do. So let's put all that together. We talked about the original color process, and let's think about what a fully digital color process looks like. And we'll start with the specification step, which is a design function. So we mentioned that the analog process or the aesthetic process is to visually evaluate color inspirations against color libraries and to work through this process of submitting samples back and forth between this customer and the supplier until we finally get some approvals, and then maybe we decide that we're missing some colors or some of the colors that were developed we won't really care for, and we're going to cancel those. So in a fully digital process, we're going to start off by measuring our inspiration colors with Color Reader Pro. We're going to select from established engineered color standards or from our own color library. So we're going to eliminate the uncertainty that comes from trying to match an aesthetic type of sample. We're going to evaluate these color palettes on screen on a calibrated monitor on material so that we can determine whether or not the color palette either needs to be expanded or decreased, or perhaps there are colors that we do not want to ask for color development. So we're going to reduce sampling, reduce physical sampling by validating that color palette on screen first before we make submissions. And likewise, we're going to utilize real color in our applications such as Adobe Photoshop and Illustrator. And there are functions within Datacolor Tools that allow you to create color libraries that can then be used within the Photoshop applications and Illustrator applications to ensure better quality color on screen. So it is possible to eliminate a significant portion of the visual evaluation of physical samples by utilizing Color Reader Pro and the Spider 5 with what we call Datacolor Envision software and Datacolor Tools. When we move to the next step of development, now is when we really need to employ the high-end close tolerance instruments, the Datacolor 800 and Spectrovision. And again, rather than working with a visual color selection process, we're going to utilize our color technology. We'll be measuring those color submissions, the aesthetic color submissions from design on these instruments, doing our searching, evaluating the color quality, evaluating things like flare. We want to know how is this particular color standard going to change from one light source to another so there are no surprises. You may have an expectation that your color is going to flare, let's say red in the secondary light source or green in your secondary light source. And so an important part of the initial color standard selection process is to validate that. And you can do that in Datacolor tools with the graphical data as well as with the on-screen color display. Now, once we have our color standards established and we move into the match process, again, we're still going to be using the same high-end close tolerance spectrophotometers so that we can share the QTX data. But our first step, rather than dyeing a physical sample, should be evaluating theoretical formulas. Again, we discussed theoretical dye recipes in a previous session, but in summary, what we're doing is we're collaborating with the supplier and their customer to evaluate potential dye combinations before they've actually been dyed. So the supplier has the ability to create, quote, a theoretical dyeing without actually dyeing a physical sample based upon the data coming from Managed Textiles. And they can share that with their customer to get input on which combination looks the best with the other products that they're developing. So it may be that the supplier submits a dye combination that flares red, one that flares green, and the customer can say, I prefer the color formula that flares red, and then we can begin our actual physical color development process. As we said before, instead of just sending the physical samples, the supplier should be measuring those and filtering those digitally against the color standard and only sending those standards or those submissions that they think have a high likelihood of success. And we're sending those electronically in the form of a QTX file. Once we do the QTX evaluation, then we can either reject or accept. If we reject, we make a correction. If we accept, then we ask for a physical sample. So in this lab dipping process, our goal is to eliminate sending any physical samples. We're only going to send digital samples until we get something we think is going to match, and then we request a physical sample, and we eliminate all that time and cost associated with sending multiple rounds of samples. Once we move into production, still continuing to make measurements on our high-end close tolerance instruments, we want to confirm the color quality. And this is where we're going to be looking at an extensive amount of data and where graphics are especially helpful. So rather than looking at individual samples, though you could look at individual samples on a run chart or on just a table, we find that using the graphical analysis is much more effective. And all of that data can still be submitted to the retail apparel customer for additional analysis, especially when we're thinking about multi-source programs or multi-component garments. So if you want to see whether or not the submissions coming from supplier A agree with the submissions coming from supplier B, the graphical capabilities within Datacolor tools support that, again, without having to have physical samples. It's really impractical to retrieve 100 production samples and evaluate those in a light cabinet. It's overwhelming, no one has the time for that. But in an instant, you can actually view that information in Datacolor tools and even on screen to identify visually any outliers if that's a part of the process for you. Once you're moving into full production, as we said before, ongoing color quality really is an essential component of the overall customer experience, and it speaks to the value of the brand itself. So we want to ensure the quality of the colors long-term in the stores or online. Again, we start with color measurement with the Datacolor 800 and Spectrovision, but then ultimately we move into sharing that production data via the Color Hub platform. And what this also enables you to do is to perform supplier assessments and material assessments. So as you go through a season or a year, whatever the time frame may be, going back and looking at how did supplier A perform, how did material ABC perform, do we have any issues that we need to consider before we move into the next season. So all these processes work together to fully digitize the color development workflow. And there are a lot of benefits that you're going to receive if you begin working towards this fully digital process. So there's some listed here. So generally would say overall process improvement is our goal. And each of these points is going to do just that. So we think about validating color palettes prior to color development. That's going to reduce overdevelopment. By reducing overdevelopment, we eliminate the cost associated with sampling, and we also get back a lot of the time that our colorists and designers spend in the light cabinet looking at physical samples. We have faster selection of color standards, filtering out unacceptable lab dips. Both of those items are going to, again, save us time and improve the overall quality of the initial submissions we receive. Reduction in costs is significant for sample development and shipping. So you're eliminating the cost of the air shipments for both samples and lab dips. Reducing color development lead time lets us wait later in the color development process to make decisions about final color selection. Coordinating colors across multi-source programs to ensure that materials from different suppliers do indeed coordinate well with each other when they're in the store. Improving overall color and giving us end-to-end visibility of product color. So significant advantages that we can realize by implementing a fully digital color process. But you don't have to do all of it to get the benefit in one area. So what I would suggest is that if you evaluate your own processes, look at those areas where you are currently using digital color management, and first say, is there some way that I can improve this part of the process? And again, that's where certainly data color, myself or my colleagues are available to you to assist you with your evaluation of that process. But then look at areas where you're not currently using digital color management of any type. So look at the design process, look at the initial color standard specification process or lab dipping or ongoing production, and say to yourself, is there an area here where I can implement even something small as a part of this process, such as Color Reader Pro, to eliminate some of the visual assessment? And then take small steps. And then what you'll find over time is as you implement these various phases and you get agreement from those within your organization, then you'll truly begin to realize the benefits of that fully digital process. And in the end, we've achieved what our primary goal is, and that is that the customer sees what the product designer intended. Because that's ultimately where the real value of any of these processes is measured, is whether or not they're effective at getting the products into the store that the designer feels are going to be the ones that sell. So that is what can be somewhat of a complex process. If you have any questions about the digital color management workflow, certainly feel free and reach out to me or to any of our data color colleagues, and we'll be certainly glad to go over it with you, and we can arrange either on-site consultations or meetings, of course, or whatever is appropriate depending upon the current circumstances. So thanks again for your attention, and I hope you've enjoyed the session. Let's think about what's happening next. In the next session, we're going to be talking about supplier accreditation for faster product delivery. And everything we've been talking about with digital color management assumes that not only do suppliers and their customers have technology, but they are using that technology effectively. And if they're not, then you really can't necessarily trust the quality of the results that are being produced. So this is where supplier accreditation can be used to ensure the quality of those results. So that's what we'll be discussing during our next session. And thanks again for your attention. And Chen, we'll turn that back over to you.
All right, Ken, thank you again. That was really nicely put everything together, all the pieces that you've talked up to now. You can see it all together. Very nice. Just the last reminder, once again, if you're looking for, you missed the previous sessions, you can go to Data Color website under the Academy area where we have the recordings of all the webinars as well as a list of in the classroom style lectures available. In addition, we have our Data Color blog where we cover a lot of industry trends, user tips, and a different advice are all available on the blog. So once again, thank you very much for your time and looking forward to the next session.